Hi all, welcome back to LearnCodeRepeat. Today's LeetCode problem is Kth Missing Positive Number. So before we look into the problem, if you haven't subscribed to the channel, do subscribe to the channel. And I'll be covering algorithm videos every week, so do hit the bell icon for future notifications. Let's look into the problem. So the problem says given an array ARR of positive integers sorted in a strictly increasing order. So the array is sorted and an integer k, find the kth positive integer that is missing from this array. So for example, if the input is 2, 3, 4, 7, 11 and k is 5, the output should be 9. Why the output is 9? Because from this array, if you see, the array starts with 1, so 1 is missing, and 2, 3, 4, 5, 6 is missing, and then after 7 there is 8, 9, 10 that is missing, and then we have 11, right? So the fifth number from the missing numbers are 1, 2, 3, 4, 5, which is 9. So that's why the output is 9. Let's take a closer look into this example. So before we go into this example, let's assume that the array is 11, 14, 15, 16, something like this, right? It starts with 11 and k is 5. So since k is 5 and from 1 to 10 the numbers are missing, right? So we can directly say the fifth missing number is 5, right? Because 1 to 10 it's missing. So we can directly say that missing number is 5. So one of the condition can be if my first integer of the array or the first number of the array, if it is greater than my k value, then I can directly return k, right? So if let's say my array is ARR, if ARR of 0 is greater than k, then I can directly return k. So this will be my first base condition. Now looking back into this example, right? So let's imagine that we have a scale here, okay, with numbers as starting with 1, 2, since it's a one index number, right? Or the array is one index, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and I'll go up to 12, right? So if we assume that the array, right, it starts with 11 like this, right? If that is the case, then we can directly return the missing value as 5, right? That means this is the pointer, right, which I can say that this number is the missing element, which is same as k, right? So first we'll start with that assumption that a missing number is k value itself, that is the number at index k, and then we'll go over the array one by one, right? So we'll go over the first number and check if that number is less than the k value. Here 2 is less than k, so that means 2 is present in the array. So I need to push my counter by 1. Why? Because we have a number 2 which is present in the array, so I cannot consider this number as missing, right? So for my k value to remain as 5, that means the number of elements that are missing to remain as 5, I need to push this to one more, right? So that way it will be 1, 2, 3, 4, 5, right? Assuming that the remaining are still missing. Okay, so we have moved the pointer to this now. Now again I'll go to the next array value, which is 3. 3 is present and 3 is less than my current k value, right? My current value or the current pointer value is 6, 3 is less than 6. So again I will increment my pointer to this, and because I'm removing 3 from here, right? So the pointer is now incremented. Again I'll go to the next array value, which is 4. I'll compare 4 with my current pointer. 4 is less than 7, so that is in the array, so that is not missing. So again I'll remove this from here and increment my pointer so that my total number of missing is still 5. It is same as k. So every time if I find an array value which is less than my current pointer value, I will increment. Okay, so now my current pointer value is 7. 7 is again less than 8, so I'll increment my current pointer, and 7 I'll remove it from here, right? Now my current pointer is at 9 and array value is 11. 11 is not less than 9. So I can break from this loop, and the final value where my pointer is 9, and that's the output that we are expecting. So if you see, what I'm doing here is I'm making sure that my pointer, if this is a scale of missing number, right, I'm making sure that my pointer is pointing to the fifth number. So when I'm going through the array, I'm checking if there is any number that is less than my pointer value, then my pointer needs to increment. So the logic for this will be, here the first condition is, if my first element of the array is greater than k, then I am returning k. This is the base condition. Then I'm creating a pointer that is same as k initially, and I'm iterating over the array. I'm checking if the value of the array, if it is less than the pointer value, which is the num value. If that is the case, then I'm incrementing the pointer, because that means that the value is present in the array. So I need to increase my counter or the pointer by 1. And if a is not less than num, then I can break the loop in that case. That means I have found the kth missing position, and at the end I am returning the num value, which is the kth missing position. So the time complexity of this will be, since I'm iterating over all the elements, in worst case I will be iterating over all the elements of the array. So the time complexity will be O of n, where n is the number of elements, and we are not using any additional space, so the space complexity will be O of 1. So time is O of n and space is O of 1. Now there is one more variation to the solution for O of n. Let's look into that. So here again, if I consider the scale, and let's say the array is this way, 1 2 3 4, right? So here from 1 to 4 there is no missing number, right? If there is no missing number, then the value at index I, right, let's say this is index I, right? So here I equal to 0 1, right? Here I is 0 1 1. So at the value of a of I, right, equal to 2, so I can always say that a of I minus, since I is 0th index, so I'll do I plus 1 here to make it 1 index. So the value of a of I minus I plus 1, if it is equal to 0, that means there is no missing number, right? So here a of I is 2, 2 minus I is 1, 1 plus 1 is 2, so 2 minus 2 is 0. Then there is no missing number. But let's say if my array is something like this 1 2 5 9, right? So if my I is here at this position, right, here it is, the value of I is 2 and a of 2 is 5, so 5 minus I is 2, 2 plus 1 is 3, so 5 minus 3 equal to 2. So I can say that till this point there are two missing number. And if you see, after 1 2, after 2 3 and 4 is missing, so there are two missing number till this point. Similarly, if I go to here, right, so here I is 3 and a of 3 is 9, so 9 minus I plus 1, 3 plus 1 is 4, 9 minus 4 is 5, so here till this point there are 5 missing number, right? So we can use this logic to determine at a given index I how many missing numbers are there, right? So let's see how we can modify this particular logic using the logic that we just mentioned. Okay, so if you see here, what I've done is I've used a while loop to go over the array, and the condition that we checked here, right, a of I minus I plus 1, right? So the condition that we checked here, right, a of I minus I plus 1, if it is equal to 0, then there is no missing number. If it is greater than 0, then there is some missing number. And if there are missing numbers, right, we just need to make sure that those number of missing numbers is less than k. So that's the condition that we are doing here. We are checking that condition here, and we are looping over the array until that condition is met. So as long as that condition is met, we just need to track the latest value of the index I, right? So that's what we are doing here. We are tracking the latest value of index I in idx variable, and I'm just making sure that I do I plus 1 because I is 0th index and the array is starting from 1 value, so I'm adding 1. So once we come out of the while loop, right, so we'll only come out of the while loop either this difference of the missing number is greater than k, or we have gone through all the elements in the array. In either of the cases, the final value of index will tell us how many numbers are missing, and we just need to add those many numbers to k at the end. So k plus idx will give us the kth value of the missing number, or the kth missing number. So we are using the same logic in the while loop, and again for this also the time complexity will be O of n and space complexity will be O of 1. Now how can we improve this O of n time complexity given that the array is sorted? Now since array is sorted, right, we don't need to go over each and every element, right? We can use binary search and just go over and divide the array and check this particular condition, right, where the index value and the index plus 1 value, the difference is less than k, then we can use that value to add it into k, right? So instead of going from this left to right, we can always divide this and check on this particular condition, and based on that we can go left or right, right? So let's see how we can use binary search here. Okay, so this is the binary search code. So except for this part and this part, the rest of the code is same as a binary search algorithm, right, where we have low and high and we calculate mid using low plus high minus low by 2, and based on some condition we increment the low as mid plus 1 or high equal to mid minus 1. So what the condition is, that is important, right? So this condition is same as our previous condition where we did array of index minus index plus 1 is less than k. So instead of index, here our index is the mid value, so we are doing the same thing, array of mid minus mid plus 1 is less than k. If that is the case, then my closest mid, that is my closest index, is mid plus 1. We are doing plus 1 because it's a 0 index, so we need to increment by 1 to make it 1 index. So we are doing the exact same thing that we did earlier, but here we are using binary search to every time divide by 2. So we are doing a log of n operation here. So my time complexity becomes log of n, and space is again same, O of 1. So once we are done with this while loop, at the end my closest mid value will have the total number of missing values that is in that range, and that I just need to add to the k value, and that will give me the kth missing number. Okay, let's try to run this algorithm on LeetCode. Okay, so I have written the same algorithm here, and if you see here I have commented the O of n algorithm. This is the solution 1, and rather this is the solution 1 that we discussed, and this is the solution 2 that we discussed using while loop. Both are O of n approach, and this is the O of log n approach. Let's submit this. And the code is accepted. So it takes 0 millisecond and it's 100% faster. So that's it for this video. Hope you like this video. If you have any questions, please do write into the comment section. Thank you.